Now it's my pleasure to bring out a colleague at UCSB who is the guy in machine learning in the world. He'll explain a lot about that. I'm very happy to work with him. I've known Igor for a while now, and aren't many people better in the world than Igor. So, Igor?
Thank you, Peter. Okay, well, wiggly, I don't think I've used that word before. English is my second language, so not sure it goes well. So it's real pleasure to be here. Thanks to Peter, the Economic Forecast Project, and also Chancellor Arsenis for having me. I'm going to try to tell you about AI for autonomous everything. How many of you have used ChatGPT or any other model? So a lot of you have. There are many other things that are AI, and yesterday we just heard the news. Yesterday we just heard the news that OpenAI's system solved an 80-year-old mathematical problem. Bad news for people like me, right? You would think. Not really. I mean, now I'm going to explain all these equations. Just kidding. No. Not really. I mean, think about long division versus calculator. It's capable of doing the things in process that are kind of a logic sequence after a logic sequence after a logic sequence, getting to the point that it wants to solve. And so it's actually, in some sense, very good news. And that's the continuation of the story that Peter just told us. But you know, emotionally speaking, this is me figuring out a new thing, and I think there is a difference. So now, what I try to do is ask ChatGPT about what is AI. And so let's try and see.
Or artificial intelligence refers to the development of computer systems and machines that can perform tasks that typically require human intelligence. It is a multidisciplinary field that encompasses various approaches, algorithms, and technologies aimed at creating intelligent machines capable of perceiving, reasoning, learning, and making decisions.
Very Stephen Hawking-ish. Maybe I should have used a better narration. But it forgot to mention communicating, which is quite important in intelligence. But besides that, you know, aside from that, it was actually quite good. But you've seen a lot of the examples of artificial intelligence that you don't really think of anymore as artificial intelligence. I mean, according to the definition, you know, perceive, reason, Google search is somehow reasoning over all these data on websites and figuring out where do you want to go. That is AI, a version of AI, right? Facial recognition is a version of AI. Alexa, that many of you have at your homes, is a version of AI. Very narrow version, but not like these modern ones. So what all encompasses an AI system? Well, first of all, you have to have perception of the environment. Here is a beautiful environment that's probably in our backyard. And then, so here is the environment, and then there is a perception, right? So you need to perceive. You have some sensors, this indicates, yeah, and then you do some reasoning and decision-making. For example, if that happens, you have a decision to make. And one of the decisions might be, you know, actuation with the legs, run, or, as people tell you, stop there and shout at the thing. Maybe it's going to go away. I don't know. If it's running like that, not so sure. But we are built for the visual. We are not built to process data that is coming out of the machines themselves, looking like that. 3 million jobs in the world in network security right now, open. Maybe we need AI in that particular context, right? This is the logs from the exchange of information between these machines, and try to find in there that person that is trying to hack into the system. That's a different kind of processing. It's massive amounts of data. Your home network is 5, 10 megabytes maybe per second. We're talking about hundreds of gigabytes per second of data floating in large networks. So I'll say something about how to resolve that particular problem. Now, we can split AI in narrow. I already told you a few examples of that. And then a general AI. There are all kinds of predictions about general AI possess the ability to understand, learn, perform any intellectual task that a human can do. Maybe not quite accurate, because think about it. I just told you that we need to have AI that's going to process 100 gigabytes per second of data. That humans can't do that. So I like to actually call it intelligence plus. It's taking large amounts of data, processing them, and making sense out of them, and then communicating with humans as to what the outcome is. Here is a little bit of history. You're probably not going to be able to see this, but I'll say a couple of things. Surprisingly enough, the first ideas of AI, the way we have it today, occurred in 1943. Amazing, right? Right around here, there was a lot of development of rule-based systems. Think about it in the context of I'm monitoring a network, or on my own network, I'm sending a file out, and maybe it's 10 megabytes of data or something like that. Is that a lot, or is that a little? The rule says, well, if you're sending more than 30 megabytes, I'll alert you. Something weird might be going on. You can immediately see that that's not perfect. AI should really figure out how much data I'm typically using, and maybe if it's 3 o'clock at night, that's a lot. But if it's 3 o'clock in the afternoon, that's not a lot, right? So those are the systems that were around here. Actually, between 70 and 80, we had what is called the AI winter. Not a lot of funding was coming in. There was a Turing test. The Turing test said, if you put the machine behind a curtain and you can talk to it and not figure out that it's human, if it's not human, then it passed the Turing test. You have intelligence, right? Probably some changes need to be done to that particular test, because we passed it in 2014, and I bet you if you use the language models that you can tell, after a while, maybe not initially, but after a while, that you're talking to a machine, not to a human. So for a short time, maybe you pass a Turing test. But in 1997, something pretty spectacular happened, and that's the IBM's Deep Blue beat the world chess champion. I'll tell you a little bit more about that story in a moment. And then 2011, Watson competed on Jeopardy. You might remember that one successfully. But that didn't go anywhere commercially, if you think about it. The commercial movement is right here in the last 5 years, right, with these very modern systems. Now, this is the original paper. This is the original image from that paper. You see, these things are supposed to model neurons in your brain, and these are the interconnections between them as the neurons are firing, and you're trying to figure out and make decisions how to move away from the mountain lion. That's what they thought might emulate logical nervous activity, and interestingly, both of them, I believe, well, at least one of them was at the Department of Psychiatry. Well, this is a modern depiction of a neural network, and it's not very different. I mean, these spiky things are now circles, but there is also some input here, like there, maybe a picture of a dog, and then the output says this is a dog. That kind of a thing. But you see the connections and the neurons. So 1943 is when this whole thing started. This is a very recent slice, very, very thin slice of a human brain disease. Amazing, right? But the modern neural networks are coming close in numbers to the number of neurons and number of connections that we have in here. Okay, so you might have seen this one. Let's see if it works. Okay.
You broke my heart, because I couldn't dance.
That AI.
You didn't even want me around. And now I'm back to let you know I can really shake them down. Do you love
Watch
me?
now.
I can really move. Do you love
Right there.
me? I'm in the groove. Do you love me?
Opa.
Do you love me? No.
I don't know if you noticed, but it almost fell. So out of many, many attempts of doing this, some work. All right? I have to do this. It's Boston Dynamics, Lakers, that kind of thing. But not good. Oh, this one is dancing, all right. And I have to finish with, now this one, but look, I grew up in Croatia. Soccer is my thing. Okay, we're gonna move on. I mean, there are real issues when you take this kind of a technology and put it on the street, and you're seeing a lot of headlines here. Dallas residents raise safety concerns as Waymo expands, Waymo recalls software after. I don't know if you've seen these, they're all over LA, and they can stop. And then you have a lot of humans in the back room moving them out of the way when they stop. So it's not entirely autonomous, right? Your language model, when you operate with it, is autonomous. It's telling you everything based on your prompts. This is not, not entirely autonomous, and there are issues with it. Superhuman. Well, we heard the story before several times, so it's going to be interesting to see what happens now, but this is Garry Kasparov. He was the world chess champion. 97, he got defeated. There was a lot of hype. Lee Sedol, a Go master, world champion, gets defeated in 2016. Very different. Remember the rules that I told you about? Very different methodology, much, much similar to the networks that you've seen that are in your language models. So neural networks, reinforcement learning, deep learning is something that we've honed over the years and developed to the level where a world champion in Go can be beaten. Now, Go is horribly complex. Chess has about 10 to the 50, 10 to 100 positions that you can have. This thing has 10 to the 320. That's, the number of atoms in the universe is about 10 to the 50, give or take. So the fact that humans are amazing at this is the amazing thing. The fact that the machine was great at it, well, it has a massive processing power, intelligence plus, right? But that's not it yet. Language models, I think almost everybody raised their hand when I asked whether you use them. This is an interesting graph. This is the number of articles that were written by journalists that are 100% human or 50% human written or AI written. And look at that. There is a large growth, right, as ChatGPT gets released and other models, and now there is a saturation. It seems that humans have said, well, it's good, but not good enough to my taste. Now, it's going to get better, but there is a saturation. And there is a commodities of language models that are out there right now. All right, the energy problem. That is a problem. Between 2017 and 23, we got the doubling of the electricity used for data centers. 4.4% of data centers now goes towards data centers. 48% higher carbon intensity than the US average. By 2028, more than half of the electricity going to data centers is used for AI, equivalent to 22% of US households. What's happening? Startups are installing tiny data centers in people's homes. Electric company says, that's Lake Tahoe, actually, this one. Electric company says it's cutting off an entire town so it can sell all of its power to data centers. Seems like bad news. Well, this is the carbon output. It doubled already from what it was right here. It's going up badly, but then it saturates. So good news, bad news, bad news. There is a little bit of good news. And a little bit of good news, well, depends on your position on nuclear power. but the good news might be that this saturation here is due to the fact that modular reactors, nuclear reactors, are growing in use. And all of this up here is renewables, solar, wind, other renewables. So that's interesting. The growth of need for energy by data centers is actually driving the rise in the use of renewables. And I should say, thanks to Jeff Henley for this wonderful building and other donors that have contributed and sponsored this development. This is the Institute for Energy Efficiency at UCSB that I'm a part of. And I gave you the photo during the night because we work day and night on this stuff. So it's a beautiful building. Walk the UCSB campus and you'll see how gorgeous it is. We are doing some. I'll show you a couple of local companies that I'm also associated with and what they're doing about this, because it's not all about additional sources of energy. It's also about, well, the GPUs. They're the driving force, the computational hardware behind modern AI. They were developed for video games originally by NVIDIA. That's how NVIDIA became so big as it is. Now, CPUs, the standard stuff in your laptops, is using 10 times less energy than these GPUs. So if you could have algorithms that run on the equivalent of CPU power, you get to 20 watts. Do you know what spends 20 watts? What has 20 watts of power? This. We're doing all of this on 20 watts of power. That should be sobering. Right? You can do a simple calculation as to how many thoughts you have per day, 60,000 or so, and you see that if you translate that to prompting, still language models are spending 10 times more power than our brains do. So we have ways to go. But there are algorithms, and I'll show you some in the rest of the talk, that enable computations of CPUs type power and low energy cost. Okay, a little bit more. What's happening now is there's a lot of talk about agentic AI. Traditional, quote-unquote, AI, I mean, 4 years old, traditional AI. Things are moving really fast. Traditional AI, you give a prompt, and it responds, right? Agentic AI, remember, perception of environment, reasoning, and then execution of actions, like running away from the mountain lion. Learning from outcomes, real-time learning from outcomes and feedback. Architecturally, language models don't have that ability. They respond to prompts, but they're actually not actively learning from outcomes. There is a whole new architecture of so-called world models that are going to enable a lot of this agentic AI. Now, of course, you say something like, clean up my email, and then it erases your whole. Yeah, you can laugh, but that actually happened. that is actually an incident that happened. The other thing that's happening is for driverless cars like Waymo, of course, we need a lot better edge AI. So the current model is you put a prompt in that goes to some cloud server. It does its own computation, gives it back, the answer. But these models that are necessary for action for our driverless cars, they have to be local to the car. You cannot call the cloud. I mean, if there's no connection, you're in trouble, and because nobody's going to need driver's licenses anymore. That was supposed to be a joke, and I was like, okay. So that's happening, edge versus cloud, and for that, you're going to need the computation. So this is a company called Mixmo that is also local, and it's you're looking at a network of computers exchanging information. I told you the volume is enormous, and then the underlying AI is actually perceiving the environment, figuring out, oh, there is something happening at 11 o'clock at night. Hey, there is some criticality. It says hi. And then it immediately goes like context, scope, reasoning. I know up there you cannot see this, but I'm going to try to narrate it. And it tells you, this is what I think is happening. And then you can do a little bit of prompting and say, well, show me the graph, and here is the graph, and here is this machine, and there are some unseemly flags that are telling me that the data is coming in from weird places, going out to weird places. If you don't know that flag, that's North Korea. So, but then you launch a language model and say, hey, let's describe this. This is critical. And then you tell it, review the last 30 days. This is weird. How come, this is happening on this machine? Well, this machine was attacked 54 times in the last 30 days. That's what the AI is going to tell you. And then you prompt more and more, and it's even going to give the analyst, well, here is what you need to do. Shut down a bunch of things, that's what it says here, and then investigate, and here is what you do to remediate. Well, no action allowed. We don't want the situation with, like, clean my email, and then it erases everything. So the final decision is left to the operator, to the analyst. But even a junior analyst can do with this particular tool. And remember, we have 3 million jobs missing in this particular 3 million people can get a job in this particular business. So we need something like this. The last example I'm going to show you, well, again, I'm a big soccer fan. So this is a little less polished, but what you're looking at is a soccer field. It looks like a football field. And you're seeing some of the players, red team, blue team. These are from Premier League. And you're seeing the ball here in the light over here. And I'm going to run the movie. And this is something that AIMDYNE is doing. So you'll see the ball going over. It was in this part, going over, passed over, and there we go, goal. So now look at the bottom. This is what the AI is perceiving. But this part here, in particular over here, is what it's thinking at the time, at the beginning, right when the sequence has begun. Not as it goes on, but what it thought is going to happen 10 seconds ahead, right? And you're going to see this mass of dark over here, and that means, I think with high probability, a goal is going to happen. Now, this prediction, real-time prediction aspect, is something that a large group of people in the world is working on. But another thing that was really beautiful to me is I was reading a few years ago this book, Clara and the Sun, by Ishiguro. If you like Ishiguro, you have to read this book. If you are interested in AI and societal implications, you have to read this book. It's a great, great, fantastic book. What was fascinating is Ishiguro, of course, is not a scientist, but when he describes how Clara, who's a robot companion, is in viewing things, he describes it as little prisms or triangles and stuff. And look, I mean, that's precisely what is happening in the AI's brain in this particular picture. Okay. I'll end with this. This part here that just happened yesterday is a sequence of logical decisions that AI makes and then proves the theorem, and we celebrate it. But there is an entirely different set of human capability that comes from almost no data, almost no kind of worldly interaction. And that's Einstein thinking of himself in an elevator. As the elevator is going down, we feel the gravity, but if there is a push force up and we balance that gravity, then you would feel weightless, like you're on the space station or something like that. Out of that thought, Einstein was able, over 10 years, I gotta say, to produce this. It's one of the most complicated equations that exists in the world of physics, but your GPS would not be as accurate, or maybe even not be accurate at all, if this equation didn't exist. He did it without almost any data, without any indication that Newton's gravity is not an entirely correct version, and he came up with that. That's the creativity and the DeepMind, Google's DeepMind. This is just January 26. These authors came out with this really interesting title that said, LLM Can't Jump. Different architecture. The world models are the place where we are going to enable all of these technologies that I've hopefully described at some level. Okay. Here is my last thought. AI will change everything. There's no going back. commerce, societal interaction, armed conflict. It's already doing that. We need a context-aware, adaptive, reasoning AI, benevolent, energy efficient. Well, there is progress to be made, a lot of it. There are also worlds to be ruined. So it's up to us. So I would encourage you collectively to engage. Not to, as Peter said, not to just listen to the evening news and say, whoo, or read The Economist, which I love reading. But those kind of catastrophic predictions, I don't know. Let's collectively engage, and together, Zach's probably going to tell us a lot about this. The world is going to look a lot better. Thank you.